I would make a note. I would take whatever your notebook is, whatever you're using for notes, and either cut this out of the paper I'm giving you or copy them down because these are going to come until you get them down. You're going to want to be able to look at these. They're pretty straightforward, not too hard. This is probably the hardest piece. Okay, so let's just do some examples, and that should get you where you need to be. So it told us that this integral, so the integral from from 2 to 6 for some function is 10. So basically what I've got is I've got some function here. I don't know what it looks like, but from 2 to 6, I know that area is 10. Then they're telling me from for 2 to 6 for g of x, that's -2, and we're going to be working with those areas. So when I'm adding two integrals, that's the same thing as saying, so I'm going to take the integral from 2 to 6 of f of x dx. I'm going to add the integral from 2 to 6 of g of x dx. I can break out these definite integrals, and I'm adding two functions to break them out to two integrals to make it easier sometimes, you know. Um, let's see here. Let me get rid of these. So they're telling me up here that this integral is 10. They're telling me here that that integral is -2. So I add those together. That's going to be -8. For this next one, we're reversing it. G of x comes first, and we're subtracting. So what am I going to do with that? So then we're saying the integral from 2 to 6 of g of x dx minus the integral from 2 to 6 of f of x dx. So this is -2, and that's 10. So 2 minus 10, -2 minus 10 is -12. When you get a constant multiple out in front of an integral, it's kind of just like what we did with the derivative, is you can multiply the derivative by that constant. So what I'm going to do is I'm going to rewrite this because this will come in handy later on when we get more involved. When you have a constant there, you can just pull that right out in front of the integral, leave the rest of it underneath, and then say, what's this integral? Well, that integral is equal to 10, it told us, right? Right there. So 3 times 10, just bring the 3 along for the ride, that's 30. Now we get down to where we need to do a little bit of thinking. So here, we've got the integral, let's see, we've got the integral from 2 to 6 of f of x dx plus the integral from 2 to 6 of 2 dx. Now, well, this is 10. But this is some other function. This is an f of x or g of x. This is that function. So this is another function. So all we're really doing is we're thinking, well, we're going to go from 2 to 6, and we know this is the line y equals 2. So that's going to be a distance of 4. 4 times 2 is 8. So this will be 10 plus 8, which is 18. So you see how we had to start. Now we had to start doing some other stuff with this, what we knew. Now we're getting to that addition, subtraction of integrals have different bounds. So this is where it's a little trickier. So do you see what they gave us here? Here, let me zoom this in so it's bigger on the screen. Do you see how we're going from 0 to 5 and then from 5 to 7? Well, if I'm looking for the integral, let's see, what is it asking me to do here? There, and then maybe from 0 to 7. So if you go back and look at those properties, it says if you have the integral from 0 to 5 of f of x dx plus the integral from 5 to 7 of f of x dx, do you see how the right here is the same number? So that means it's just kind of like a breaking in the middle. It's breaking at 5, so we're just gonna merge them all together. So if I add those two together, that's the same as the integral from 0 to 7 of f of x dx. And of course, that's what we're looking for. So this integral is 10. This integral is 3. If we add them together, we're going to get that whole integral will be 13. Okay, so we mushed them together. This says 5 to 0. So now what's happening is up until this, and this is the first time you've seen this, the B number is bigger than the A number. So what we can do is reverse the order of those bounds. And what that does is here, just a minute. We can rewrite this as the integral from 0 to 5, so that way the smaller number's on the bottom. But because we reversed it, we got to stick a negative in front of it. If you think about this as in terms of going backwards instead of walking forwards when it's normally a low number to a high number, well, by reversing it, that means we're going to go backwards. So basically what you're going to do is you're going to change the sign of that integral. So the integral from 0 to 5 is 10, so that answer is going to become negative 10. And we already talked about this one the other day. When there's no change in the width, right? If we're going from 5 to 5, there's no change because those limits of integration that's called are the same. The area is 0. And then now we have that constant multiple again, 3 times the integral from 0 to 5 of f of x dx. So that's just going to be 3 times 10, which is 30. Okay. Okay, so what's the difference between the average value of a function and the average? The average, how do we word that? The average rate of change, right? So for this one, there we aren't really getting average rate of change, but just I kind of let me digress a little bit. When we did f of b minus f of a over b minus a, that was what we were going to use with that mean value theorem for derivatives, right? Remember that's just the slope of the secant line. If I have a function and I've got some interval in that function, the mean value theorem says this slope between the 2 points where this is a and this is f of a and this is b and f of b. Then we said there's some point C here where the derivative of the function at C is the same as that slope. That's where the mean value theorem. And this is the average rate of change for the function. Now what we're trying to figure out is, hey, we got some function, right? We've got some function. We want to know if we average those all out. And if you think back to some work you might have done in elementary school, what you did with blocks is you leveled those blocks out so they're all the same. This is what we're doing here. I mean, maybe you remember that, maybe you don't. If you don't, that's okay. What we're gonna do is what is if we averaged out the function, what would it look like, and how high would the rectangle be? So to answer his question here that he set up to find that average of let's see, f of t represents one way to start to measure the temperature at equally spaced values, right? And then average those temperatures. So basically, what we're doing is we're doing a RAM, right? Here's some function. Here's T1. Here's T2. Here's T3. Here's T4. Here's T5. T6, T17, 17, 8. And what we do is we do width times height, and then average those all out, right? So it would be f of t1 plus f of t2 f plus f of t3 and f of t4, and we'd be adding all those up all the way to f of t sub 8. And then we'll divide those by however wide those things are. I mean, a 24-hour period, and we've got 8 intervals. Wouldn't that be 3 wide? Okay. And if we wanted to write that as a Riemann sum, what would that be? We'd take the limit as n goes to infinity of the integral of the sum, not the integral, of the sum of I equals 1 to n, and then we'd say f of x sub I times delta x, right? That would be the Riemann sum expression, and we could evaluate it. There's really nothing we could do much more than that. Now, if we wanted to do this as a integral, we'd say from a to b. Actually, you know what? I'm sorry. Let's. That's the Riemann sum. Then we're going to divide by however many. rectangles, or however many sections we're going to have. And then another way to write that is 1 over n, right? So here's what we can do with an integral. And this is the average value of a function formula. So it's going to be the integral from a to b of f of x dx, but then we're going to divide it by n. And one way you can figure out what n is, you can divide it by b minus a. Remember, this is a constant, this is an infinite number of rectangles here. So if we just divide by how wide it is, let's see, where's my pointer? This gives us an infinite number of rectangles, and we'll just divide by how wide it is, okay? How many intervals we have. Maybe that's confusing right now. Let's go look at some problems. Let's look at some examples. Okay, so we're going to graph x squared. So 0, 0, 1, 1, 2, 4, 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so there's that graph. There's that function, right? And now we want to set up the integral, and we know that the shading, that we're looking for this area right here, aren't we? So that would be the total area. And then if we were going to use our graphing calculator, we're going to do FN. So you do math, press the math button, press 9. I'm writing the word 9 out. Press 9, and then you'll get the integral symbols, and you'll type in 0 to 3 of x to the second dx. Hit enter. The calculator is going to tell you 9. The calculator will tell you 9, and then yeah, and then to find the average value, we've got to divide that by 3, because remember how the formula is right there. It's 1 over b minus a, and in this case, b minus a is 3 minus 0, so we're going to divide that by 3. So that'll give me an average value of 3. Okay, and we'll learn how to do that by hand later on. In fact, I think once we get back here, once we get through this section, this 5.3 section. So does this function ever have that value? Well, let's see. Where is y equal to 3? Well, isn't it right? Isn't it right about 1, 2, 3? It's right about there. So that's where it happens. At what point does it assume this average value? It looks like at about 1.5. It's about 1.5, 1.5. The function has a value of 3. Does it? How about if we do this? Since this is squaring, I get a better answer than that. How about with the square root of 3? That's where it happens, right? Because if we square root 3, that's going to be 3. So that's a better answer. Let's see. What do you suppose the relationship between the area and the x-axis and the area of the curve on formula is the width? This is it's a rectangle, right? It is a rectangle. So the average value would it be this rectangle right here? I don't know, honestly, what he's thinking about there. This is how we find the average value, folks. That's useful when you're dealing with, just like you want to know what values. Well, yeah, I guess that we're answering that exact question is what value for the function. See, we're not finding the area now, because remember how we're dividing by 3 again. So this takes it back to a rate almost. So it's similar to the mean value theorem of derivatives, just a different way to do it, because we're not looking for the average rate of change for that function. We're looking for when is the function achieving that value. Let's see here. Here's what he's trying to get you to think about with this part, with 11, 12, 11, and 12. Here's the integral that would find the area under the curve, so be looking for that area, right? And then what's the dimensions of the shaded of the other rectangle? Well, that's b minus a to get that distance. We couldn't do a minus b because that would be a negative number, right? So b minus a times the height, which is f of c. Whoops, what am I doing erasing all that? And then, so then if we think back, if these, well, let's think about the average value formula. So if I have the average value, and we know that that is f of c, because we did that up above, and we know that 1 over b minus a times the integral from a to b of f of x dx, if we just multiply this side by the b minus a, I've got that expression. So we can play around with this, and with this formula. I wouldn't get too hung up on it though, folks. This is how we find the average value. And remember, it's not a rate of change we're finding, it's a value on the function. Where does it make a rectangle? Don't get too sharp. Too sharp. I guess the only thing I want to say about what's written on this page is this right here. The average rate of change is the slope between 2 points. That's the f of b minus f of a over b minus a. And the average value of the function is 1 over b minus a times the integral from a to b of f of x dx. That's what you want to keep straight in your mind, because it will throw both of them at you. Maybe in the same problem. I know I've seen AP questions that have the same problem, so that both in the same problem. So um, yeah, I guess that's all this video. This is probably long enough. Get to work.